Good evening, everybody. Welcome to the TMLS Macro Summit, the finance focus today. We have a very exciting talk today around putting your first ML model into production. What should be your considerations and examples? I remember the first time I put a model into production, and you sort of never quite forget that experience. But we are in great hands today with Sabina, who is the principal data scientist at Altair Engineering, doing data analytics consulting. Sabina has years of experience working as a data science professional, including doing a variety of projects at points and currently doing a variety of different use cases such as credit, risk, marketing, and engineering process design. Sabina also has a master's in ecology from University of Guelph with focus on data analysis and modeling in R. So this should be a fantastic conversation today. Everybody, please feel free to submit questions on the right side in the chat box, the session one. I will be taking a look at those and then ask those questions to Sabina in about 20 to 25 minutes when we are ready to wrap up. So with that, why don't I turn this over to Sabina?
Thank you very much. I'm really happy to speak at this new way of going through summits and conferences, and hopefully everyone can see my screen. And as Monish mentioned, if you have questions, feel free to type them in and we can discuss at the end. So I saw this quote on a colleague's desk a few years ago, and it really spoke to me, especially when we think about machine learning. It's easy to try and come up with a machine learning model and think that it's a really great model, but a lot of work has to go into actually making it available for production and making use of this model. So today I want to go through some of the steps when you start thinking about getting your models into production. So we'll start from the very beginning for assessing business needs for machine learning, to setting KPIs, prototyping your first models, deployment methods, and then building that pipeline that will integrate well with your business needs and infrastructure, and finally closing that feedback loop. So today I'll cover phases 0 through 2 on getting your machine learning models into production. Phase 3 is a later phase once you actually have something in production, how you continue to optimize. So we won't focus on that part today. We'll start out with the phase 0, the first phase of determining whether it's the right time to build machine learning for your system. First and foremost is trying to map out your use cases. This is a finance-focused summit. There are a variety of different use cases that would be relevant to you, such as loan approvals, credit cards, upsell and cross-sell between different products. Even within financial organizations, there's marketing and targeting, preventing fraud, etc. And often, many of these different use cases are linked to one another, so even marketing targeting might have to work really closely with assessing the risk of different customers. So once you actually map out your use case, the next important thing to think about before you even start building your models is to determine what are the KPIs that you care most about. These KPIs should affect your business outcome in some way, whether that's bringing in new business and you're concerned about tracking things like conversion or basket sizes, whether you're more concerned with saving money by detecting and preventing fraud or reducing risk, or you're thinking more along the optimization route of reducing costs of doing business. So all of the different KPIs that you need to think about, you should set those out at the very beginning so that when you're building models, you can assess your models against these different KPIs once you actually launch these models. So let's take a an example here on how to think about the KPIs and different model objectives. So let's think about fraud. You might have a model where you want to identify potentially fraudulent transactions on a credit card, but it's not just enough to, identify and prevent this fraud. You might also be very interested in identifying large transactions that, if you don't catch them, have a very big impact on your business. You might also have KPIs around reducing false alerts from your models. Let's say if these false alerts have to actually be assessed by real life humans, and you have agents that are working on these, you might have a lot of time that needs to be spent on manually investigating all of these alerts. So you have to weigh these different KPIs and figure out which ones are most important and how you actually track against these KPIs with the model. So if we take two really simple examples of different models, and we look at the accuracy of a model just as one of the metrics. Let's say model 1 has 76% accuracy, whereas model 2 has 94% accuracy. We might be inclined to go with model 2, but if we actually look at it from a business perspective, the second model actually caught a lot of small fraud transactions but missed the large ones. However, also reduced false positives, so it reduced manual agent checks. So you have to take all of these into account when you're building out your models and matching them to the appropriate KPIs. So once you've actually figured out these KPIs, you can think about how you integrate them with the model objective. So the likelihood for transaction to be fraudulent and the amount that, let's say the amount is what you're most interested in. The next step is actually mapping these objectives and KPIs to getting the right kind of data that will be used to build out your model. Once you have this data, you take a first pass at the model, you start prototyping, mapping those KPIs with the outputs of the models, and importantly, checking these results with business subject matter experts. So an example here, let's say we start creating a fraud model and we model it on some sample data and we test it on an out of time sample. And we look at these KPIs such as dollars in fraud caught by the decile of the model. So, the top 30% most likely to be fraudulent transactions. If we were able to identify those, how much fraudulent dollars would we be catching in time? So this prototyping step will be used to show value to different stakeholders and will be validated by the subject matter experts. So once we have something that we think could make a difference in the bottom line or the KPIs of the business, we go on to the next step, which is the model deployment phase. So model deployment is very broad, and essentially making model outputs available for decision making can be done in a variety of ways. The bottom line is we need to be able to have some sort of business action taken from the output of the model. You might imagine that the complexity of infrastructure required to deploy different kinds of models or different types of complexity of models will vary. So you can have something very simple. Let's say you're doing something in batch. On your laptop, you have a Python script, and let's take a collections example now. On a daily basis, you run a script to predict which of your customers are most likely to pay you back if they receive a phone call. And you run this daily, create an Excel spreadsheet that you give to your collections department, and then they go ahead and call the people on your list. And you rank order them with the most likely to pay back if they receive a call. So that's very, very simple from an infrastructure point of view. But it's only done in batch. And it's very prone to a lot of errors, human errors, in terms of the handoff between departments or some of the process that goes behind making this viable. In terms of increasing complexity, you can start adding a little bit more infrastructure and more process around this with a database. So you might be able to run, let's say on a nightly basis, a model that scores new data that you've gotten for the day and stores those outputs in a database, and they can be accessed in batch as well from the database. You can start to mix and match batch and real time as well. So you might have a database in which you, let's say on a nightly basis, calculate certain features on your data, certain aspects of your customer, and then you use that to score some data in batch. But you might also get parts of the customer's behavior in real time. So you can access some of this data that's already been scored or already been processed in batch and use it in real time. And finally, you can also just have real-time scoring where all of the data preparation happens in real time as well as scoring. And as you can see, that is on the more complex end in terms of not just infrastructure, but also usually the teams that are involved and working together to make this a reality. Okay. So let's talk about how to actually get there, how to think about building and deploying your first pipeline. This pipeline needs to be determined in part by business needs. So where the model is deployed. So again, are you giving an Excel spreadsheet to a collections department, or are you running a website where customers sign up for a credit card and in real time get essentially a response on whether or not they were approved. So you have to determine, can you live with a batch process, or do you really need to have a real-time process? And based on that, what is the infrastructure that's needed to support either one, and all of the teams that would need to be involved to make this a reality? So a simple example with batch that I mentioned before is that you can very simply take all historical data that you've captured, build a model, generate predictions on new data, have a simple list, and you can give that to another department and have some handoff process there. An increasing complexity, let's say you have a data science team and a software engineering team, and the software engineering team maintains a centralized database, and there is a handoff procedure between a data science team that creates a model, and that model generates predictions, and the predictions get stored in this centralized database. This database can be accessed by other departments, or it can even be accessed by specific applications that would be able to use this prediction data. So this connection handshake between a database and an application is usually maintained by IT or DevOps or an engineering team. An important aspect of this is the feedback loop. So having predictions actually living in a database and having them served to departments or an application makes it easier to keep track of what the model predicted and looking at this feedback loop of what actually happened based on that prediction. So if you had a phone call to see if someone would pay you back in a collection scenario, you can look at, did they actually respond to that phone call? Did they end up making a payment, or did they not make a payment within a certain amount of time? The last example of a setup for real-time scoring, the handoff actually happens a lot sooner, or can happen a lot sooner from a data science team to an engineering team. So the data science team can create a model and hand off that model to a different team that manages the entire process of taking the model, putting it into staging and production, and making it available for real-time scoring, the predictions of which can be served up to an application. So this is sort of offloading a little bit more off the data science team and more onto ML ops or DevOps type of team. just wanted to mention a few tools that might be useful for actually having real-time scoring models deployed. So for example, if you're working in Python and creating scikit-learn models, you might use PMML, which is language agnostic language that actually can work between different platforms. So for example, between Python and Ruby, you can use Flask to create apps. You can use Docker. If you're working with Spark MLlib, there's MLleap. These are some tools, but there are a lot of other tools out there that you can use for deploying models in real time. Some considerations for deploying models, again, as I mentioned, what are the business needs? Do you have to make a decision in real time? Can you work with batch? And also, what is the current architecture and infrastructure that you have in your organization? And can you work with IT to make any changes? And if you do need to make changes, what are the costs associated with these changes? And which teams do you need to get involved, such as engineering, DevOps, or IT? And how to manage that handshake between the model that a data science team creates and the outcome that an end user or a customer sees at the end of the day. So with that said, I have a real example here of what I actually deployed when I was working at Points as part of the product team there. So this example is for real-time hotel ordering. So for a customer landing on a site to book a hotel, we wanted to, in real time, order hotels that are most likely to be booked at the very top of the page. So I'll walk you through the infrastructure and the processes that we put in place to be able to get from my laptop and a bunch of Python code to having something running in production. So I prototyped my models using Jupyter Notebooks and scikit-learn for the model. The actual environment was maintained with Docker images that we centralized and we used for reusability. Once the code was reviewed, as well as the actual model and the results looked good to the subject matter experts, that code was moved into a GitLab pipeline. The GitLab pipeline itself created artifacts. So the artifact that we used in this case was PMML code. So the model was represented as PMML. And we also generated model evaluation metrics. So we wanted to keep track on things like the AUC for the models that were generated and a few other things, including just, it was images of the model itself. It was a decision tree model, as well as the rules that could be evaluated by a subject matter expert. Once we generated the artifacts, we were linking to these artifacts in Jira. So we tracked the model ID and we actually associated that with a software release. So each software release could potentially get a new model that would end up in production. So that was the handshake between teams was done in Jira. From Jira, the developer team could take the model and load it into a staging environment and run automated tests. This was happening in Ruby. So one of the reasons we use PMML is because I developed my model in Python and the application was actually built in Ruby. So we had a Ruby gem that would be used for real-time scoring of the model. Once the model, as I mentioned, past the automated testing in the staging environment, it was actually moved to the production environment, but it was not on by default. For that, we actually built an A/B testing interface where we could schedule tests. And once models became available, we could take those models and not just one model, several models, and actually schedule them to have them running on certain percentages of traffic. So I might take a model and do a 50-50 split with another model, or if we have 3 models being tested at the same time, we could split the traffic accordingly. We actually later built the multi-arm bandit infrastructure as well, in addition to having A/B testing. Once the model was scheduled for A/B testing and it went live, we built a reporting infrastructure to capture model performance, different KPIs that we're interested in, such as conversion and basket size. And we not only just took into account these KPIs and monitored them in a report, we also stored all of this data back into the database so that later we can run more customized reports using Python. And we can also just use this data to further refresh and update the models. So this is a real example of actually getting a model out to production. A next important thing is not just the first time you do it, but also how do you manage the life cycle of actually getting more features into the model and iterating over that model within the infrastructure that you created. So there's a lot of different aspects to think about infrastructure-wise before launching a model. I'm not going to talk about all of these, but I'll briefly talk about some of the items outlined in orange. So a little bit about data. So one of the things that you really need to be careful with is that features created for model training have to be available for scoring. So any data prep that you've done before training your model needs to be available when you score that model. So if it's in real time, you need to be able to do those calculations in real time. So you should ask yourself, can these calculations be done in real time, or are they very expensive? So do you need to calculate them in batch first and just make them available in real time? And also you need to have a process for creating new features. So whichever team is in charge of the application and the ETL for storing the feedback data needs to be able to follow exactly the same data prep steps that you've taken so that the data is usable and you can track it and you can track calculations and any changes that you make to the data. There needs to be process around deployment. So I've talked about different handoff between teams, different sign-offs that have to be done. In this case that I've explained, we use Jira, but any tools can be used to track who is doing what, any data changes, and if the pipe does break, which team is responsible for fixing which parts of the pipeline. So this is very important because models can explode in production. It has happened to us, and it's good to know who to talk to when certain things break and how to debug things. Monitoring and reporting is also something that needs to be built out either through getting dashboards, custom-made dashboards to track these KPIs, whether you're doing that just by having Jupyter notebooks with reports, or you build an actual page with real-time reporting and monitoring. This needs to be thought out, and it would be the part that requires the data to be stored and analyzed as the model is in production. So for the fraud example, want to monitor maybe predicted fraud versus what is the actual fraud, and any dollar amount caught in terms of fraud. And usually, as also recommended, is to have a way to A/B test. So often you might have multiple models that you want to test in production to see which one is better. You might also want to test business rules over models. So if you're starting with a model for the very first time, you might have some business knowledge encapsulated in making decisions. So you want to be able to test a model against already in place business rules and see if you are adding any lift over that. And you also want the ability to test the KPIs for significance. So for example, if you're looking at basket size between two different models for different offers, you might want to see, is this basket size significantly higher than the other basket size for the different model? And finally, closing the feedback loop. So this is, again, one of the things I want to stress the most is that whenever you have A/B testing and champion challenger, and you promote models, you need to be able to track when this happens. You need to be able to track which model was in production when, what the outcomes of the models were. So not only just the prediction, but what ended up happening, so that you can evaluate how the models are doing, if they're degrading over time, if you need to change models, etc. So closing the feedback loop and getting that data back into your database for further analysis is a very critical point, and is an often overlooked or afterthought in this process. So sometimes you might be able to track experiments with Google Optimize, but maybe there's no easy way to get this data back into your database. So things that you should think about on how you're going to track how the models are doing in terms of your KPIs. So some of my closing thoughts for this topic is that building the correct infrastructure to actually get models in production takes a really long time. But the important part is build it in a way that allows for iteration and allows you to track how different models are doing. And there will be many bugs, and it's important to have some way to track who is responsible for different parts of the pipeline, so the bugs can be fixed and you can easily figure out where the errors are coming from. And data scientists will often need counterparts of data engineers to work with on getting the right data pipelines, and software engineers to actually have the right infrastructure to be able to have models in production. And as I've said before, don't be discouraged if you have a model actually explode in production. It can happen. The important thing is to be able to debug quickly, or take things down, or have some sort of backup when things are not working well.
Thank you, Sabina. I'm going to jump in the interest of time. That was such a great session. And we can tell that by the number of questions that we have. We have a lot of questions today. Thank you so much. If we were in a hall, we would all be clapping, but we can't do that today. So I'm going to try to combine some of these questions, because there's a bunch of them. There seem to be a number of questions around roles that different people play within the sort of the different part of the process. So there's sort of one question around, who is responsible for monitoring and reporting? Who is sort of generally responsible for performance tuning, like data scientists or engineers? Do the rest of the engineering team get involved, not just sort of data scientists? Like what are the handoffs like, right? So there's a number of questions around the process and the different roles that people play within them. So maybe you can sort of speak to that. I know I've sort of expanded the question a little bit.
Okay, sure, yeah. So in my experience, I've had first interactions with actual software developers. So these developers have helped me create the right environment to build models in. So having the right infrastructure for model building, as well as a deployment pipeline. So the GitLab pipeline that I described was set up by more of a software engineering type of role. And building out the approvals in there is part of just my experience, as well as their experience, and figuring out how approvals work based on our own just business requirements. In terms of further handoffs, the team that manages the actual application. So let's say you're launching a machine learning model in an application that is, let's say, a website where you're approving customers for a credit card. The ownership of making sure that the model works there tends to be with the team that's building out that application. And they're also responsible for, or not saying that they they should be responsible for the data that's generated by that application. So as a data scientist, we don't usually have access to production level data. So we need to make sure that whatever we actually see was what that application will continue to generate. So we built our model on certain features. We're expecting that the data used to generate those features will continue to work in the same way. So I'll give you an example of something that happened to me. I created a model that I mentioned in this example, and I had a feature called is business class. So it was a binary flag on trying to identify whether a customer was booking a hotel for business reasons or leisure. Now, we had the model in production for several months, and a subject matter expert said, well, I think maybe we need to tweak our definition of business class, or sorry, business traveler versus leisure traveler, and we should make this change to the data prep pipeline. And I had a question from another team saying, okay, so I'll go ahead and change the definition, change the equation that generates this flag. And I said, wait, no, don't do that, because it's going to change how I currently make the models. And I have certain assumptions about that, and it will mess up my current pipeline. So create this as a new feature to make sure that you're not interfering with the work in my pipeline for creating this model. So there is a lot, you have to work to figure out who will take responsibility for which part of the pipeline. Usually the data scientists are limited to what they have access to and what they can do in terms of changing data. So it's usually the other teams that take responsibility for the stability of the infrastructure as well as the integrity of the data that's created. I don't know if that sort of helps answer that composite question.
No, thank you, Sabina. I think it definitely does, and there's sort of many more questions around interpretability, around A/B testing. What I'm going to ask, if you don't mind, maybe to sort of stick around. I'll have to sort of go off to other sessions, and maybe some of these attendees will have to go off to the other sessions as well. But maybe those that want to stick around and talk to Sabina and ask her questions, please stick around and ask your questions within chat. And I hate to say this, sorry, but you may have to sort of repeat a question you've sort of put up before, just to sort of indicate that you're still in this session and you would love sort of feedback from Sabina on that. So if you don't mind, if you could please do that, that would be great. But otherwise, again, thank you so much for this session. As you can sort of see from the number of questions we have, you have really provided a lot of information and got everybody thinking. So thank you.
Thank you, everyone, for... Okay, so I'm just reading through some of the questions here. There's quite a lot. I'm going to scroll up to the top. So can you talk a little more details about A/B testing and invariant KPI metrics for the model? So in the example that I gave for A/B testing, we were looking at 3 metrics that we're tracking, which was conversion on whether a customer actually booked a hotel or not. We also looked at the sort of basket size. So what was the average nightly rate for a hotel? And another metric that we looked at is revenue per search. So we wanted to see, it was a combination of the amount that people were paying for hotels as well as conversion. So it was a composite metric. So we wanted to test whether the different models we had in production had significantly higher or lower KPIs compared to the other models. So it wasn't enough just to track them, but we also wanted to A/B, like do significance testing. So do we have significantly greater conversion or significantly higher basket size? So that was a very important aspect on declaring whether a model was better versus another model. And in addition to that, we used a champion challenger framework for the A/B testing. So if we declared a model to be statistically significantly better than another model, the loser would be retired, and we would build another model that would come in as a champion, sorry, as a challenger to the champion model. So then we would A/B test the challenger against the champion again and just go through that process over and over. Another question, who is responsible for monitoring and reporting? That's a great question. It depends on, for an organization, whether or not you have a centralized data analytics team that monitors the performance of different products, or if the data science team is centralized and monitoring all of their models. In this example that I gave, I specifically asked for a dashboard to be created for this process, for these models, because they were newer and not part of dashboards for other products. So it really depends on the structure of the teams, and it depends on whether the products have some monitoring for their performance already, and if you can integrate the KPIs you're monitoring directly into those dashboards. So an example might be if you have systems already tracking customers and transacting on your system, would you be able to also track what the prediction was for offering them a product or an upsell? And if so, can you integrate that directly into your dashboards, or do you need to make new dashboards that you as a team own? Okay, another question here. Did you have anyone on your team who is overlooking the whole production pipeline and possibly connecting different frameworks and tools to work with each other? Can you please elaborate about that? Yeah, so part of determining this entire framework had a principal engineer that looked at the architecture and made certain decisions based on what our current systems were in. So as I mentioned in that example, that product was in Ruby. So some decisions had to be made based on existing infrastructure. So you want to have someone with some experience in architecting entire systems together to make sure that the pipeline is sound and it makes sense. Another question is, what kind of automated tests were run in the staging area? As far as I understand, machine learning models cannot be tested the same way as traditional software is tested. So we actually did simple tests here. We wanted to make sure that the predictions that we were getting out of the model on data that we already knew that what the outcome was. We want to make sure that it matched so that we had the right model in production. We also just tested, we're keeping track of the prepared data in staging. So whenever we generated a prediction for how a hotel should be ranked, we actually looked at the input data in its prepared form, and we wanted to make sure that the data preparation was done properly and that the model was giving the correct prediction based on how the data was prepared and sent to the model. So it was a simple type of tests. Let's see. Okay, so another question is, if I'd like to build an app that has a machine learning model in the pipeline in the future, which way is better? Firstly, build a traditional pipeline without the model. Secondly, add the model later on, or from the very beginning, we design the pipeline with the machine learning model in mind. I would personally go for designing the pipeline with the machine learning model in mind, because a lot of work has to be done ahead of time to make sure that the data would be available. There's a lot of upfront work on creating data pipelines, storing the right kind of data, making sure that the data is prepared in the right way. So I would start with having the machine learning model in mind. The reason being, in addition to just making sure the right data is available, is a lot of choices are different if you have a machine learning model in mind at the very beginning. And it's very hard to go back and change existing infrastructure to accommodate a machine learning model versus building it with that in mind. Even if you launch without a model in the first place, you should plan for it in your design. Let's see here. Based on my experience, would it make your job more effective if data scientists work with production data? So that is an interesting question, and there are different ways of thinking about it. So some organizations might think about having a data lake and just dumping a lot of data in one place and just throwing data scientists at it and just say, have fun, like make, can you give us some value from all the data in a data lake? And that will just require a lot of data scientists' time to look through all the data and do a lot of work in processing it. On the other end of the scale, if data scientists have less access to data, maybe more process data, not really production data, but certain views that are curated and created for them, they may be more specialized to creating that mining view that data scientists usually need, but they may not have visibility on what other data might be available. So they may not have as many ideas or insights on what else they could use to improve their models. So it really depends on how much time you want to spend doing some exploration and looking through data, figuring out what data is more valuable, versus having curated data that's been processed a lot that data scientists can access. Another question is, would I do something differently if I could? There are other tools nowadays that we can use, including using Docker and Kubernetes for deploying models. So I would probably try to experiment with that and see how that would work in this particular example for real-time hotel ordering. The process that we built worked, but I'm sure there's better ways of doing it, and it would be nice to have a chance to experiment with different tools and methodologies and architectures. Another question is, does the engineering team get involved during all the prototyping research before the handoff? Yes, so I think it's a very important question. So the people that are familiar with the data from the application standpoint should be involved. Also in terms of, any constraints regarding feature creation. should be discussed with data engineers as well as software engineers. As I mentioned, sometimes some features might be very costly to calculate in real time, and it may not be feasible to have model scoring in real time. And the decision might be to calculate it offline in batch and make it available in real time. So definitely want to involve both software engineers and data engineers in the prototyping research phase. Okay, I think I got most of the questions. Well, thank you everyone for participating. And if you have other questions, we can also talk later on, or send me a message, can add me on LinkedIn, and we can chat.